What we're looking at here is an expanded view of two of the layers of the TCP/IP stack. So first off, we have the transport layer, and then right above that we have the application layer. Now in a previous video we discussed some of the applications that make use of the transport layer and their port numbers. So in this example we're visually showing you the TCP and UDP port numbers that are used to support different conversations between networking devices. So what you'll notice in this application is that if you're going to recognize, analyze, and be able to report accurately on the different attacks that you see as an analyst, you're going to need to know which applications use TCP and which applications use UDP as their transport. And you're going to also need to know the ports that they use. Now, IANA controls the port numbers. Some applications that we use quite often have assigned dedicated port numbers, and that's what we see here. For example, FTP is assigned TCP port 21. More specifically, it's assigned both TCP and UDP port 21, but the application itself makes use of TCP as its transport layer protocol. The same is true with Telnet and HTTP. They are both assigned port 23, and as an application they make use of TCP as their transport. We have TFTP and SNMP discussed previously, and those make use of UDP as their transport mechanism. The port numbers that are assigned to those applications are UDP port 69, or more specifically just port 69, and port 161 for SNMP. SNMP is also assigned port 162. Now in most cases what happens is we have a server, and that server is running a daemon on it. Now the daemon listens on one of these port numbers. When a client application tries to connect, it is assigned what's known as an ephemeral port, which is a high number port that is dynamically selected, and that is used as the source port, while the destination port it tries to connect to will be one of these well-known port numbers, again depending on the application. These port numbers are defined in RFC 1700. The ephemeral ports are port numbers that are above 1023, but we typically see them in the 65,000 range. Anything that is numbered 1023 and below is considered a well-known port by IANA. One application here, DNS, makes use of both TCP and UDP for its transport. It's assigned port 53, and it depends on how the application is used as to whether it'll be TCP or UDP based. Again, having a good understanding of TCP ports and how they're used will make a difference for you acting as an analyst and being able to report the different application attacks, being able to do that accurately, being able to recognize them, and really being able to analyze them. In this example, we have server number 1, which is running a daemon that is offering web services. A user, client A, client B, or client C, is going to establish a connection to that web server. So what happens is, as the TCP segment is created on client A, B, and C, the destination IP address will be determined. That'll be done using DNS. We know that we're making an HTTP connection because of the application that is in use on the client computer. And so it will select port 80 as its destination port. It is going to select an ephemeral port, a high number random port as its source port number, and it'll go ahead and make that connection. So as the TCP segment travels from client A to server 1, server 1 receives that connection request and has to go through the three-way handshake. Now you remember with that three-way handshake there's a reply that comes back. We called that a SYN-ACK. the SYN-ACK is going to be directed to that ephemeral port that client A selected, port 49741 in this case. So in the return packet, or the return segment from server 1, it'll have a destination address of 10.10.10.10 with a destination port of 49741, and the source address will be 10.99.99.0 with a source port of 80. So right now we have this server and it is handling 3 sessions at the exact same time. And that's not a problem. These 3 sessions are distinguished by 5-tuple information. 5-tuple information includes the local IP address and the local port, as well as the protocol. So the protocol would be HTTP, the remote IP address, as well as the remote port. So this differentiates between each of these 3 sessions. Now in this example, client A and client C are using an identical ephemeral port number, 49741. But because of the 5-tuple information, their source IP address is different, and the server can maintain a unique session for each of these devices.